Alright guys, I'm back. It's part 2. Okay, so next up we're going to talk about the effect of latitude on climate. So, Earth is a sphere, big surprise, and it's tilted on its axis. So solar radiation strikes different parts of the Earth's surface at an angle that varies throughout the year. Sorry, throughout the year, not the year, the year. At the equator, the sun is almost directly overhead at noon all year. At the north and south poles, however, the sun is much lower in the sky for months at a time. So you'll notice that there is a difference in heat distribution with latitude, and this has important effects on Earth's climate zones. So you'll see from this diagram that there are 3 different climate zones. There are polar, temperate, and tropical. And then same thing down here. Tropical, temperate, polar. So, the polar zones are cold areas where the sun's rays strike Earth at a very low angle. These zones are located in the areas around the north and south poles. Then there are temperate zones that sit between the polar zones and the tropics. Because temperate zones are affected by the changing angle of the sun over the course of a year, the climate in these zones ranges from hot to cold, depending on the season. And then the tropical zone, or the tropics, are near the equator. So you can see right here. And these receive direct or nearly direct sunlight year-round, making the climate almost always warm. So just to summarize, polar are cold areas, temperate have hot and cold seasons, and tropical have direct sunlight and they're always warm. So next up, we're going to talk about heat transport in the biosphere. So unequal heating of the Earth's surface drives winds and ocean currents. So here's a figure that shows the different winds. So our polar easterlies, our westerlies, our northeast trade winds, our southeast trade winds, again our westerlies, and our polar easterlies. And it also shows the ocean currents as well. So Earth's winds and ocean currents interact to help produce Earth's climates. The curved paths of some currents and winds are a result of the Earth's rotations. So these help to transport heat throughout the biosphere. Winds form because warm air rises and cool air sinks, which creates currents. And similar patterns occur in Earth's oceans to create ocean currents. So continents and other land masses can also affect winds and ocean currents. Land masses can interfere with the movement of air masses. For example, a mountain range causes a moist air mass to rise. As this happens, and the air mass cools and moisture condenses, forming clouds that bring precipitation to the mountains. Once the air mass reaches the far side of the mountains, it has lost much of its moisture. The result is a rain shadow, an area with a dry climate on the far east side of the mountains. Okay, so key concept. Together, biotic and abiotic factors determine the survival and growth of an organism and the productivity of the ecosystem in which the organism lives. So I've included at the bottom just a little picture right here of an ecosystem. So you can see the abiotic factors, so the air, the wind, the light, the temperature, the gases, the water, the soil, and the sun. And then you can also see the biotic factors. So looks to me to be a rabbit and a fox or a coyote. So now, remember how I said we were going to talk more about habitat and niche. So we're going to do that now. So habitat is the area where an organism lives, the natural home or environment of an organism. And this habitat includes both biotic and abiotic factors. So here is a picture of some African elephants and their habitat. So you can see both the abiotic factors, the air, the soil, the clouds, the water, and then the biotic factors included here being the acacia trees and the grasses. So 4 things that have to be present in order to make up a habitat are space, food, water, and shelter. So these 4 things right here. All right, so next up is niche. So niche is the full range of physical and biological conditions in which an organism lives and the way in which the organism uses those conditions. So what you might notice is physical, abiotic, biological, biotic. So, for example, the part of the description of an organism's niche includes its place in the food web or food chain. Another part of the description might include the range of temperatures that the organism needs to survive. And then, like I stated above, the combination of biotic and abiotic factors in an ecosystem often determines the number of different niches in that ecosystem. So what is present in the ecosystem affects the number of different niches. So that determines, are there going to be a lot or are there going to be a few? Now, an organism's niche also includes food. So here we have our picture of our bear patiently waiting on his picnic table for food. It's very cute if you ask me. And in reality, here's the more reality of the situation of how a bear actually obtains its food. So eating berries and fruits and other such things. And then so the niche also includes food, how it obtains this food, and which other species use the organism as food. So in the case of a bear, nothing's necessarily going to eat a bear, but it will be decomposed when it dies. So back to our bullfrog example. A mature bullfrog catches insects, worms, spiders, small fish, or even mice. Predators such as herons, raccoons, and snakes prey on bullfrogs. So more on niche. So here's that picture we saw yesterday again. So we remember when I said yesterday that no 2 species can occupy the same niche and the same habitat at the same time. So that's why they avoid direct competition and exploit different resources. So these 3 species of North American warblers, shown in the figure at right, live in the same spruce trees, but feed at different elevations and in different parts of those trees. The species are similar, yet each warbler has a different niche within the habitat. So back to niche and what it includes. Physical conditions and reproduction are also included, which I didn't list on the last slide. And just like I just said, no 2 species can share the same niche in the same habitat. However, species can occupy niches that are very similar, such as the 3 warblers on the screen living in the different parts of the spruce tree. So now, lastly, just to kind of tie up, think of an organism's habitat as its address. This will help you out. Habitat, address. And think of the organism's niche as its occupation, so its job. And so just to kind of show that, here's a picture. This is a garter snake. It lives in most places you see today, so I'm already like the dialogue. So I'm a garter snake. I live in most places you see today. I live in forests, fields, and marshes. Those places are my habitats. My niche or job is to eat things like this. So that's a frog. And not only do I eat frogs, I also eat small fish, mice, birds, and eggs. Or sorry, mice and bird eggs. So that is all part of the garter snake's niche, but that is not all of it. There's a lot more that we just talked about. So that about wraps this up, guys. Let me know if you liked this or not, because I'm curious. I want to do what works best for you guys. So talk to me about it. Finish your note-taking guide. This one I actually am going to collect. So I repeat, I am collecting this note-taking guide.